Alright, now let's look at shortened notation for nuclear reactions. Shortened notation for nuclear reactions. So you can be given a nuclear reaction in the exams, and then they'll ask you to write the shortened notation for that nuclear reaction. How do we go by situations like that? So first of all, we have some things you need to know. So anytime you are given a nuclear reaction and you're asked to write a shortened notation for that nuclear reaction, first of all, you write the parent nuclide. The parent nuclide is written first. Is that okay? The parent nuclide is written first. So once you are done writing the parent nuclide, then the projectile and ejectile particles are written in brackets. The projectile particle is a particle that is bombarded with the parent nuclide. That is a projectile particle. So in our first example here, our parent nuclide is a nitrogen with a mass of 14 and then a proton of 7. The nitrogen is bombarded by an alpha particle. So the alpha particle here is a projectile. Is that okay? Now, after the bombardment, there is a new element that is formed. That is oxygen with a mass 17 and then a proton of 18. And then a particle was released. That particle is a proton. So the proton here becomes our ejectile. Is that okay? So after writing the parent nuclide, you then write the projectile and then the ejectile. I've explained the projectile and ejectile particles as well. And it is written in brackets. You write them in brackets with the two separated by a comma, please. It is very, very important. Is that okay? That is the second thing. And then finally, the resulting product or the daughter nuclei are also written. So the resulting product is the product or the daughter nuclei. So in the exams, when you're asked to write the shortened notation for this nuclear reaction, we said first of all, the parent nuclide is written. So the parent nuclide here is the nitrogen. Here, so you write your nitrogen with a proton of 14, and then, a mass number of 14, a proton of 7. And then in brackets, you write the projectile. Our first projectile here is the alpha particle, and it's separated by the ejectile by a comma. Our ejectile is the proton there. Is that okay? And then you close the bracket, and then you write the parent, you write the daughter nuclide or the product, and that's oxygen with a proton, a mass of 70, and then a proton of 8. Is that okay? So this is a shortened notation for this nuclear reaction. You write the parent, and then in brackets you write the projectile and then the ejectile particles separated by a comma. Is that okay? And then you then write the daughter or the product nuclide. Is that okay? Alright. Now let's consider the remaining examples here. So here, what's our parent nuclide? This is our parent nuclide. And then, where is the projectile? This is the projectile particle. And then we have our ejectile particle here. And then also we have our daughter nuclide. Is that okay? So how do we write this shortened form of this nuclear reaction? So quickly, we write our parent nuclide as the fluorine. And then in brackets, we write our projectile. We have our alpha particle separated by a comma from the ejectile. And then we write our daughter nuclide, Na here also. This is a shortened notation. Is that okay? And then the next one here as well. Our parent nuclide is our Pb. And then in brackets, we write our projectile separated from the ejectile particle, and then we write our daughter nuclei or the product. Is that okay? Now the very last example, our parent nuclei. Is that okay? Then in brackets, our projectile separated from the ejectile, and then our daughter nuclide or our product. Is that okay? So that is a shortened notation for nuclear reactions. So anytime you're in the examination, you're asked to write a shortened notation for any given nuclear reaction. You write the parent nuclide first, and then in brackets, the projectile and then the ejectile. The projectile is the particle that is bombarding the parent nuclide. And then the ejectile is a particle that is released alongside the daughter nuclide. You write a projectile and ejectile in brackets or parentheses separated by a comma, and then finally you write the daughter or the product nuclide as well. Sometimes you can be given the shortened notation and then we'll ask you to write the expanded form of this nuclear reaction. So in an easy way as well, you first of all write the parent nuclide and then you add the projectile to the parent nuclide. So our projectile here is the proton, that is the protium, and then you bring your yielding symbol or the sign, and then you write the daughter nuclide, and then you add the ejected nuclide, the ejected particle. Is that okay? So in case you are giving the shortened form and you are asked to expand, you first of all write the parent plus the projectile particle, and then you bring your yielding sign, and then you write the daughter plus the ejected particle. Is that okay? So that is a shortened notation form of nuclear reactions. Is that okay? Now let's look at some tabulated differences between nuclear reactions and then chemical reactions as well. Is that okay? Alright. Now let's look at some tabulated differences between nuclear reactions and then chemical reactions. Some tabulated differences between nuclear reactions and chemical reactions. So for nuclear reactions, elements may be converted from one form to another. For nuclear reactions, we know that in nuclear reaction, there is a decomposition or breakdown of an element to form another element, or and one element can be bombarded with a particle to form another element. So it means that one element can be converted to another element in nuclear reaction. But for chemical reactions, no new elements can be produced. It's just a rearrangement of the elements. No new element is produced in chemical reactions. Is that okay? So this is one difference between a nuclear reaction and then a chemical reaction. Now another difference is that for nuclear reactions, atomic numbers may change. For nuclear reactions, atomic numbers may change. So once an element is decomposed or broken down to form another element, there can be changes with regarding its atomic number. And you've seen that in our previous examples that we've gone through. Is that okay? So there might be changes in the atomic numbers for nuclear reactions. But for chemical reactions, there's no change in atomic number. So we say atomic numbers may change for nuclear reactions, but for chemical reactions, there's no change in atomic number. This is also another difference between nuclear reactions and then chemical reactions. Another difference is that for nuclear reactions, the neutrons and protons are involved. So even in the lesson that we just did on the shortened notation, we could see an atom or an element bombarded with a neutron or bombarded with a proton. Is that okay? So the protons and neutrons are involved in nuclear reactions. But for chemical reactions, it only deals with the valence shell electrons, or the valence electrons, or the atomose electrons. So for chemical reactions, it is only about the valence electrons, but for nuclear reactions, the neutrons and protons are all involved. That is the particles in the nucleus. Is that okay? Now another difference is that nuclear reactions are not affected by external factors. These external factors can be temperature, pressure, concentration. Is that okay? Nuclear reactions are not affected by these external factors. But chemical reactions can be affected by temperature. Temperature can change the form of a chemical reaction, whether it's in an endothermic form or it's in an exothermic form. Concentration. We can change the concentration of a chemical reaction. So concentration can affect chemical reactions. Pressure can also affect chemical reactions. But all these external factors can't affect nuclear reactions. Is that okay? Another difference is that in nuclear reaction, large amount of energy is released or absorbed. Large amount of energy is released or absorbed in nuclear reaction. We were looking at the concepts of nuclear fission and nuclear fusion. Large amount of energy is released in this process. Comparative to chemical reactions, it is going to be a small amount of energy that will be released or absorbed in chemical reaction. Nuclear reactions also is not affected by catalyst, but chemical reaction is affected by a catalyst. I hope you know what a catalyst is. A substance that speeds up a chemical reaction. So for chemical reaction, catalyst can affect them, but for nuclear reactions, catalyst does not affect them at all. These are some tabulated differences between nuclear reactions and also chemical reactions. Now, let's look at how do we determine the stability of a nuclide. what account for the stability of a nuclide? We'll be talking about the neutron to proton ratio in the nucleus of an atom, the binding energy of a nucleon. We will be talking about half-life. Is that okay? All these factors account for the stability of a nuclide. We will take them one after the other and then we explain them as well. Is that okay? Thank you.